The last time we talked about how we can find centroid of the area or the line. And to start with the example for the line. So today we are going to start with the example for the area. See how we can find the centroid of the area. Probably quickly. I'll do an example. So the first one, assume I have an area like this. And I want to find its centroid. X, Y, and what is it? Y is minus X, and B and H. B. H. I want to find the centroid for this shape. I have here is the equation for that. So if you want to start to solve that, find the centroid, the first is that we have to take an element as the area. So we have two choices. Either we have the choose the vertical element with dx, or we can choose the horizontal element with dy, depending on, and both of them will give the same result. So I'm just going to follow what the book did. The book shows the horizontal element. So if we go there and assume we have the horizontal element like this. If this is my horizontal element, so this is going to be dy. And then the other way, so dy. And then I need, so basically anytime I'm working, there are three things that I need. I need to know the x, the centroid of the element, the y for the centroid of the element, and the dA. These are the three things I have to find. So the coordinate for the centroid of the element and the area for the element. So the coordinate for the element is this. If this is the centroid of the element, it has a coordinate of x tilde, y tilde, and if I bring it down here, then x tilde forget that this is the x. The tip of the element from here to here is the x. So it's going to be half of it. But from here to here, where it actually hit that is the x. So that's half of it. And then hit this distance, the y tilde would be what? Remember, the x is going to be always from the beginning to the end of the element, so that's going to be the x. That's the x. Up to here. That's the x. So that's half of it. So next is there's that. For the element, I want to write the equation, I have to find the x tilde, y tilde, and dA. look at here, my element has a dy in it. So I have to go ahead and write all the equation as a function of y, because that's a dy. So I have to write all the equations as a function of y. So the first one that I want to do is that here I know that the y is h over v minus x. So if I have that, I can write the x, because I need to write everything as a function of y. X is going to be v minus b over h y. So that's the first. So the first equation I wanted to be as a function of y. So my x is a function of y. Then I have the x tilde, which is going to be half of x. So it's going to be half of that b minus b over h over y. So just replace x with that x from there. The next one is y tilde, which is y, which is already a function of y, so I don't need to do anything about it. And then I have the dA. dA is the area of that element. So the area of the element is x times dy. The length of it is x, the height is dy. So it's going to be x dy. It's going to, again, I have to rewrite it as a function of y. So I replace the x with this. So it's going to be b minus b over h y dy. So these are the value I need. Now for the x bar, it's going to be x tilde dA over dA, and y bar is y tilde dA over dA. So it's going to be, so x tilde is half of b minus b over h y. That's the x, and dA is b minus b over h y dy. Again, dA is b minus b over h y y. For y bar, have the same thing. For y tilde is just y, and then have the b minus b over h y dy divided by b minus b over h y dy. And I'm integrating over y, because the dy I'm integrating over y, so it's going to be from 0 to h. The limit for my integration is going to be y is 0, y is equal to h, and 0 to h, y is 0 to y equal to h, 0 to h. So this one is going to be, the two is going to be b over 3. This one will be h over 3. So remember when we were talking about the centroid of the triangle, we said this is a 1/3 from the base, always. So if it's a 1/3 from the, so it's going to be in either of direction, it's going to be 1/3 from the base. So that 8/3 or 8/3 that we use it, we already use them in distributed load, but it comes from here. Question? Let's look at one another example. So X, Y, and Y is equal to X squared. One turn here. So they're gonna work with this one in two different ways. That way. Again, I have this shape, I want to find the centroid. The first step, I have to find the element for that. So the element for that, it can be either parallel to the x or parallel to the y. Depends on which one was. And you can see the difference here. So the first step looks at, okay, let's have it like this. So it's going to be that's going to be the dx. And then I have to find the centroid for that. Remember that this distance is x. So x tilde would be x, as I said, this is going to be x tilde and y tilde is the centroid of the element. And this is the y tilde. This is going to be half of the y. To make it a little bit to see, it is the point there. This point here, the coordinate of x and y. The coordinate on the curve has coordinate of x and y at each point. So look at here, I have the dx, so my element is as a function of x. So I have to write all the equations as a function of x. The y should be as a function of x, the x tilde should be as a function of x, the y tilde should be as a function of x, and dA should be as a function of x. So I would write all equations as function of x. So here the y is already as a function of x, so I don't need to do that anything, so I just write it y is x squared. Then I have the x tilde is x, so I don't need to do anything about that either. Then the y tilde is y, the half of the y. So I will go ahead and replace the y with from this equation, from the very first equation. So it's going to be half of the x squared. And then the dA, the area of that is going to be y dx. And again, I want it to be function of x, so again I replace the y with x squared from here. Is it there? So it's going to be x squared dx. So now I have my equations as a function of x, all my equations. And then I have x bar is integration of the x tilde, dA, y with y dA, and y bar is the dA divided by. So it's going to be integration of that. X tilde is x, dA is the x squared dx, and dA is x squared dx. For the y, going to be y tilde, which is going to be half of x squared dx, which is x squared dx, and dA is the x squared dx. The range for that, I'm integrating over the x, so I would go from the x0 to maximum x, which is 1. I'll go from x0 to x1, 0 to 1. So x0 to x1. And so you can plug it in your calculator to solve it. double check them, see if they're correct.
That's what I did.
So next I'm going to do the same problem, but this time I'm going to consider the horizontal element. So everything is the same. Y equal to so this time instead of having the vertical element, taking the horizontal. It's going to be somewhere there. That's my horizontal element. That's going to be dy. The location on the curve here is x and y, centroid of the element is x tilde, y tilde, and that's going to be x tilde. So the y tilde is y. The x tilde is a little bit different this time. So, put it this way. From here to here, how much is that? It's x. From here to here,
One minus x.
1 minus x. So now, I want it from here to here.
One minus x over t plus x.
X tilde is that okay?
1 minus x over t plus x.
Yep. So it's the x plus half of this. So it's going to be x plus half of 1 minus x divided by 2. And that's going to be 1. So now I have the dy, so I have to write all the equation as a function of y because I have the dy. So we'll go ahead and I will write all the equations as function of y. So the first one that I need to write is that y is x squared. So the first one that I need to convert it is that the equation of the curve itself. So x is gonna be y to the power of half. So that's the first one. Then I need the x tilde. X tilde is x plus 1 minus x divided by 2. I want it to be a function of y, so x tilde is gonna, I replace it from there. So it's gonna be y plus 1 minus power of 2. I just replace every x with the square root of y. And then y tilde will be y. And the dA, okay, is this distance, but the dA is also a little bit different from it. The length of the element is 1 minus x times dy. So it's going to be 1 minus x times dy, and then I want it to be complete as a function of y. It's going to be 1 minus y to the power of half dy. So now I have these three, but I can use it in my x and y equation. So x bar would be x tilde dA over dA. It's going to be x tilde is going to be plus 1. The dA 1 minus 2 y. Taking off there. 1 minus y. Y bar. Tilde dA divided by dA. So y tilde is just y. dA is 1 minus y. This time you are integrating over y. Again, it's going to be 0 to 1, but it's over y. So it's going to be from y equal to 0 to 1, y equal to 1. Y from 0 to y equal to 1. And it's going to give you the same. Also, it's going to give you 0.75 meter here and 0.3 meter. So as you can see, both of them will give you the same answer. Depend on the shape that you're integrating. One of them is easier to work with. So for example, here you see that this element here is much easier to write it and integrate it compared to this. In some other shape, it would be the other way around. It would be easier to do it this way rather than this way.
Is there a certain reason for that we should look out for?
Well, when you do the practices, you will see that. For example, in the previous one, when we had that rectangle, you see that there's not that much difference.
Yeah.
Because it just starts from here. The reason that this one is not that easy is because it starts at the, it's not a start from the y-axis, it starts somewhere in the middle of that axis. If it was flipped, probably would be the same both way. So I'm going to move on from this part one more time. Regardless of the shape, we decide what type of element we hire, vertical or horizontal. Based on that, we write all the equation based on x or y and then we calculate everything from the both of them. So we either calculate both x bar and y bar using this element, or we calculate both x bar and y bar based on that element. Okay. Next, previous section that we talked about is that if you are given any shape, how we can calculate the centroid of that. In this section, we are going to talk about what if that shape we have is made of non-geometrical shape. For example, made of triangle or rectangle, trapezoid, those shapes that we are already familiar with them. If this is the case, we can do the integration, but there is an easier way to solve if we know the geometrical shape. So, for example, if I have a shape like this, or I would say, if I have a shape like this. If I have shapes like this, I can go ahead and break them into the shape that I already know their centroid. For example, I can go ahead here and break it down in two shapes. Let's say here's this part here and this part here. I can break it in two shapes that I know it's central. The same here as well. I can go ahead this way. I can break it in the other way, but I'm not going to break it this way. And I have two shapes. One's going to be this, and one's going to be this. So basically, if the area I'm given, I can break it to the shape that I know their centroid. The equation that we are using is going to change. So if I have x bar is x tilde dA divided by dA, I can rewrite that I can replace that with the sigma. So it's going to be sigma x a divided by sigma a. And the same here for the y. It's going to be y tilde dA. I can replace that with sigma y tilde divided by it's going to be the same if I have the line. If I have a line, the way that I can, for example, assume I have straight line and then half a circle. Again, if I can go ahead and break it into two parts from here, it gives me two shapes that I know is centroid. So one of them is a line, one of them is half a circle, and I know the centroid for both of them. Same here for the line. So for the line I have this bar is x tilde dl or dl, and y bar is y tilde dl or dl. I can replace them with the sigma, so it's going to be tilde I l I can replace them. In both cases of them, remember the x tilde and y tilde are 4 in the x. So for the centroid for each element. Element and can be positive or negative. So both of them can be positive or negative. One way is that if I have a hole, that for example, assume I have a shape like this. And there's a hole in there. So if I have a shape like that, I can go ahead and say this assume that's going to be x and y. So I can say this is equal to entire shape y x minus this is the minus the whole. So I'm gonna have, when I want to work with that, I'm gonna have 3 areas. I will break them into 3 areas. So that area will be 1. Second area will be 2. And this area will be 3. And the area for the hole is negative. So in our calculation, the area of hole is negative. So when we put it in this equation, we put that in this equation, we consider the area as a negative. I'm going to do one example to actually show you how we do that, but that's the entire idea. So if we can break the composite shape into the shape that we